Have you ever looked at a fraction like, say, 1/8 and seen how it becomes a nice, clean decimal, but then 1/3 just goes on forever? 0.333. It's not random at all. There's actually a secret code hidden inside these numbers, and today we are going to crack it. And listen, this isn't just some neat math trick. This is the key to guaranteeing you get full marks on this type of question in your exams.
So here's our game plan for today. We'll start with the core mystery. Then we'll do some detective work on the denominator. After that, we'll uncover the why behind it all, lock in the official rule, and finally build a foolproof strategy you can take straight into your exam hall. Let's dive in.
All right, so every rational number, which, is just a fancy way of saying a fraction, has a decimal destiny. It's either going to terminate, which means it stops, or it's going to be non-terminating, but repeat in a nice, neat pattern. The real question is, why?
Just look at these two right here. On the left, you've got 3 divided by 8. It gives us a perfect, clean 0.375. It's finished. But on the right, 1 divided by 3 gives us 0.333, and that little 3 just goes on for infinity. So you've got two totally different fates from two pretty simple fractions.
So that brings us to the big question, right? How can we possibly predict this fate without having to do all that long division? There has to be a shortcut. And spoiler alert, there is. And it's been hiding in plain sight this whole time.
The secret, the entire clue, is hidden in just one place. The denominator of the fraction. Yep, that bottom number. So let's put on our detective hats and investigate a few cases to see if we can find a pattern.
Our first piece of evidence is this number, 15.265. Now, we can see it's a terminating decimal, right? It just ends. So our mission is to turn it into a fraction and then take a really close look at its denominator.
Okay, step 1. Let's write it as a fraction. That's easy. It's just 15265 over 1,000. Now, and this is an absolutely crucial step, don't forget it. We have to simplify it to its lowest possible form. When we do that, we get 3053 over 200. The number we really care about here is that denominator, 200. Okay, now for the really important part. Let's break down that 200 into its prime factors. What do we find? Well, it's made of just 2s and 5s. That's it. That's our first major clue. Let's keep that in the back of our minds.
Let's try another one, something way simpler. 0.4. Again, we know this one terminates. Let's see what its denominator is hiding.
Converting is a piece of cake. That's 4 over 10. And when we simplify it down, it becomes 2 over 5. So, our new denominator of interest is 5. And the prime factorization of 5 is, well, it's just 5. So let's think about our evidence so far. Our first denominator had only 2s and 5s. This one has only a 5. Are you starting to see the pattern emerge?
Let's lay all the evidence out together. The denominator for our first number had prime factors of 2 and 5. The second one only had 5. And if we go back to our original example, 3/8, well, the denominator is 8, which is just 2 cubed. The pattern is crystal clear. For a decimal to terminate, the denominator of its simplified fraction must have only powers of 2, powers of 5, or a mix of both as its prime factors. Nothing else.
But why? Why only 2s and 5s? What's so special about them? The answer isn't some random coincidence. It's literally the foundation of our entire number system. I mean, think about what a terminating decimal really is. 0.3 is just 3 over 10. 0.75 is 75 over 100. 0.125 is 125 over 1,000. See? They are all just fractions where the denominator is a power of 10. That is the whole key.
And what are the prime factors of 10, the very number our decimal system is built on? It's just 1, 2, and 1, 5. That's it. That's the entire secret. The only building blocks we have to create those powers of 10 in the denominator are 2s and 5s.
And from there, it just follows perfectly. If 10 is 1, 2, and 1, 5, then 100, which is 10 squared, is just 2 2s and 2 5s. 1,000, or 10 cubed, is 3 2s and 3 5s. This is why the rule works. To create a denominator that's a power of 10, your only ingredients can be 2s and 5s. So now that we actually understand the logic behind it, we can confidently lay out the formal rule, the theorem, that you're going to need for your exams. This is what ties it all together officially. And here it is, the formal rule you need to know. A fraction, p over q, will have a terminating decimal if its denominator, q, is made up only of prime factors in the form 2 to the power of n times 5 to the power of m. The second you spot any other prime factor in there, a 3, a 7, an 11, anything,
The game's up. It's going to be a non-terminating decimal for sure.
Knowing the rule is great, but using it to save you time and work, that's even better. Let's see how this knowledge lets us convert a fraction to a decimal without doing any long division at all.
Let's take 7 over 25. First, we factorize the denominator. 25 is just 5 squared. Now, here's the clever part. To make a power of 10, our 5 squared needs a partner, right? It needs a 2 squared. So we just multiply the top and the bottom of the fraction by 2 squared, which is 4. That gives us 28 on the top and 100 on the bottom. And we know instantly that 28 over 100 is 0.28. See? No long division needed.
All right, this is it, the final and most important section. Let's combine everything we've just learned into a clear, 4-step strategy that will guarantee you get full marks on this question every single time.
Here is your foolproof method. Step 1. Reduce the fraction. This is the most important first step. You can't skip it. Step 2. Factorize the new denominator. Step 3. Check those factors. Are they only 2's and 5's? And finally, Step 4. Conclude. State your answer clearly and with confidence.
And for that final step, step 4, here is the golden sentence. You should write this, or something really close to it, in your exam. Since the prime factorization of the denominator is of the form 2 to the n, 5 to the m, the rational number has a terminating decimal expansion. This tells the examiner you don't just know the answer, you know exactly why it's the right answer. So, there you have it. To wrap this all up, here's a final challenge for you. Take a look at these two fractions, 1 over 7 and 7 over 160. Using our 4-step method, can you tell me which one of these will have a non-terminating decimal, and more importantly, can you explain exactly why? Think about the prime factors. You've got all the tools now. Go on and crack the code.